The evolution of the story of the third interstellar object ever discovered, 3I Atlas, continues as we learn more about this interesting and somewhat enigmatic visitor from another star system. There have been a lot of developments over a very short time indeed. The first comes from the Soft X-ray Imaging Telescope, EXTEND, on the X-ray Imaging and Spectroscopy mission by JAXA, Japan's space agency. The new image in X-ray actually has a really wide field of view that extends 3 million kilometers around 3I Atlas, and they detected a faint emission glow that extends about 400,000 kilometers from the nucleus of the comet. The object has never been detected in X-ray before, though it has been observed in most other frequencies. X-ray emissions, at least faint ones like this, are a known phenomenon of comets. They were first detected with Comet Hyakutake in the mid-90s, and have been seen in a number of comets since. So this is not an anomaly, but an expected emission. But there was a mystery in that the other two interstellar objects we've detected did not emit detectable X-rays, which is why this team observed Atlas. But you have to remember, the other two objects did not have large comas, whereas 3I Atlas does, meaning you're going to get stronger emissions overall from a large coma, increasing your chance of detection. This observation was actually made a month after 3I Atlas's brightest point at perihelion, because of the pesky problem that affects all space telescopes, the zone of avoidance. You can't point these instruments anywhere near the sun, which is also why Hubble and James Webb couldn't observe it either when near the sun. The risk is simply too great of accidentally pointing it at the sun and burning out the instruments of the spacecraft. This observation had an enormous effective exposure time, 17 hours, where it perfectly tracked Atlas's motion through the constellation Virgo. Basically what's happening here is that the cloud of gas around Atlas is causing the X-ray emissions through interaction with the solar wind. Basically the wind of the sun exchanging charge with a gas, and the result is an X-ray emission. From this, the researchers were able to observe emission components of nitrogen, carbon, and oxygen from the object. For more on this, link in the description below to the Astronomer's Telegram post announcing the finding. The next development comes from the Atacama Large Millimeter-Submillimeter Array, the famous ALMA, in Chile. This one is rather intriguing in that it detected methanol and hydrogen cyanide. What happened here is that in the time spent in the interstellar medium, these molecules form on dust grains in the deep freeze of space. And they are both hallmarks of solar system comets, but here they are found in an interstellar comet. Hydrogen cyanide is found commonly in the universe, and indeed has been found in the atmosphere of Saturn's moon, Titan. It has also been seen as a gas in the coma of comets, and is an important prebiotic chemical in that it and methanol are precursor molecules to the complex organic chemical processes that lead to amino acids and nucleobases. This means that at least the very beginning of prebiotic chemistry is occurring throughout the galaxy, it would seem. But this is not rare chemistry. Methanol is seen in star-forming regions routinely and is a building block for more complex chemicals like amino acids, found in carbonaceous chondrite meteorites, and linked to comets and asteroids, and sugars like those recently found in the samples from the asteroid Bennu. Methanol is also food for some microbes, which work by using enzymes to convert methanol into formaldehyde, another important compound in prebiotic chemistry. The profile of these chemicals in Atlas was interesting because the production of hydrogen cyanide was depleted in the direction of the sun, but the methanol increased in that direction. The methanol appeared to at least partially originate from the coma, whereas the hydrogen cyanide appeared to originate directly from the nucleus. Weirdly, the ratios of methanol and hydrogen cyanide are among the largest ever seen in any comet, other than the somewhat anomalous solar system comet C2016 R2. The object produces much more methanol than hydrogen cyanide, so this represents an interesting anomaly, but not a unique one for a comet. More observations by this satellite are slated and should yield even more information on the object's chemistry. The next news story was expected. Atlas has now moved far enough from the Sun to no longer be in the zone of avoidance for the Hubble Space Telescope, and we have a new image. Hubble and the object were separated by 286 million kilometers when the image was taken on November 30th. In addition to the image, Hubble took more data that hasn't come out yet, including ultraviolet spectroscopy that should give us more chemical data on Atlas. Next are the observations of the European Space Agency's Jupiter Icy Moons Explorer, or JUICE. This interplanetary spacecraft was able to use 5 of its science instruments to make observations of Atlas. It was somewhat uniquely suited to the task as opposed to other spacecraft. We won't see most of this data, however, until February of 2026, because JUICE is currently using its high-gain antenna as a heat shield, basically to protect it from the sun on its journey. JUICE is still en route to Jupiter and won't get there until 2031, so it has to rely on a lower power medium gain antenna to send data. This happens at a significantly lower rate than what the spacecraft will be capable of when it gets to the Jupiter system, but it did image 3i Atlas with its navigation camera. This was taken 2 days before the comet's closest approach to JUICE, roughly at a distance of 66 million kilometers. Pretty distant, and remember, a navigation camera really isn't designed for observations like this. JUICE, however, does have a high-resolution camera, but we have to wait until February for those images, as with the other data it collected. The data itself will include particle data, composition data, and spectrometry. It's important to note here that while images coming out from amateur astronomers are visually more impressive than many of the images coming from the NASA and ESA spacecraft, leading to much criticism from the public, it pays to remember that the amateur astronomers are using instruments that were specifically built to observe faint objects like 3i Atlas, with the exception of a few instruments such as Hubble. To put that into perspective, take the ESA mission ExoMars. It imaged 3i Atlas at its closest approach to Mars successfully, but perhaps not very impressively until you realize that 3i Atlas is 50,000 times fainter than what the imaging system was designed to image, which is the bright surface of Mars from orbit. This was way out of the specs of the camera, yet it still pulled it off. Whereas a typical telescope in the amateur astronomy arena is very specifically designed to image faint objects. A good example here is the Hubble image. You're only seeing the coma, but some of the amateurs have really nice wide-field telescopes that can image the coma and the whole tail. Now, the issue of AI channels and 3i Atlas. Beware. There has been a lot of really incorrect information being spread on YouTube these days by AI channels. Famously, there was a channel with a digital Avi Loeb saying things that Dr. Loeb certainly never said that was badly incorrect. And people noticed that the clock in the background of the AI fake Avi always showed exactly the same time. Dr. Loeb contacted YouTube and got the channel taken down, but it goes to show how this problem is growing. So you want to be careful with your sources for valid information on Atlas, and go to the known reliable astronomy channels made by humans, and make sure when watching my channels or Fraser Cain or any of the established reliable astronomy sources that you actually are on our channels, because you know we'll all get copied at some point, and my voice already has been stolen by at least one AI channel, and it's only going to get worse with AI. Back to 3i Atlas. It's worth noting there that there was another detection of hydrogen cyanide in early September by the James Clerk Maxwell telescope. This observation was interesting because when repeated a week later, the production of hydrogen cyanide had increased significantly. It's also worth noting that several days ago, Atlas left the zone of avoidance for the James Webb Space Telescope, so expect new images from there soon. Another interesting development came in September, when a study by Guo and colleagues found that Atlas may have passed within 3.3 light years of 25 known stars over the last 10 million years. Yet it's not very likely that it passed any as close as it did the Sun, but we can't know for sure. Its energetic outgassing, though, may indicate that this is the closest ever stellar encounter for Atlas, potentially including even its star of origin, as there is chemical evidence that Atlas formed beyond the frost line of its star. If it were a red or orange dwarf, that might not be the case, but at type G and above, it definitely got closer to the Sun than its parent star. But we also don't know what kicked Atlas out of its original star system. If it was a stellar encounter, it may have gotten closer to that star, but an encounter with a giant planet also could have kicked it out. This video is not a complete list of all of the recent results. Basically, every instrument on Earth that could do useful observations of the object have done them, including observations from the ESA Trace Gas Orbiter and Mars Express. Trace Gas managed to get a photo with its camera, but Mars Express did not, too short of an exposure time for the camera to have caught it. Also, China's Tianwen orbiter also photographed it successfully. 3i Atlas will make its closest approach to Earth on December 19th, but even that isn't very close. Atlas will pass about 170 million miles from Earth. Compare that to Earth's average distance from the Sun, which is nearly half that at 93 million miles. Another future observation will be that of the Juno spacecraft when Atlas makes its closest approach to Jupiter at just 33 million miles. There's been some talk of Atlas coming very near Jupiter's Hill radius, the point where Jupiter's gravitational influence outweighs that of the Sun. But I expect that to change, because it won't make its closest approach to Jupiter until March 16th, and this object changes very rapidly and often. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently noticing 3i Atlas is outgassing beautifully and having a grand old time. Can't blame it. Imagine the boredom of spending 7 billion years in the emptiness of interstellar space. Though imagine what it's seen. Its original star system, the giant planet or passing star that ejected it, passing near other star systems on its journey, and now encountering an alien civilization that's watching it. Puts things into perspective, doesn't it? And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.